So today we are discussing about introduction to big data and understanding the fundamentals and technology and impacts on large scale for data analytics in modern digital era. And I'm Sarchit. I'm a student of computer science engineering in Acropolis Institute of Tech and Research Indore. Let's start with the topic. So here we're gonna discuss about what is big data, what are the 5 V's framework, and technologies and tools used, and real world application. These are the main content. And what is big data? We are gonna understand about the definitions, characteristics, and evolution, how big data evolved over time, and data beyond traditional processing capabilities. Okay, and basic definition is what we are gonna discuss, and the second topic, the second content we are discuss about is the 5 V's framework: volume, velocity, variety, veracity, and value. The core dimensions of big data. These are basic 5 V's that we are going to discuss about in this video. Technologies and tools. Basic Hadoop, NoSQL databases, Spark, and iCloud Prop are like basic tools used in data processing and big data. And for the last fourth one is the real world applications, like how big data is used in real world and how we can use it in our like day to day things, like industrial uses, um, industrial use cases, benefits, and future trends. What are the future aspects of big data analytics? How it can affect the modern world tech. So let's start. So what is big data? Big data is basically nothing but extremely large, extremely complex, that exceeds the capacity of traditional database systems, requiring specialized tool and technologies for storage, processing, and analysis. Basically, it's a very large data in different formats, different files, and different data sets. Like it contains every kind of data, and that needs to be sorted and scaled, right? So the second is what are the scale challenges? Data grows exponentially. Of course, data grows exponentially because like data is always increasing from terabytes to petabytes and beyond, like requiring much distribution to the solution. Like complex structure includes like three type of data, like structured data, semi-structured, and structured data. We all know, like data from diverse sources, like many sources are storing at a place, like social media, IoT platforms, and transactions, and like hospital management systems and everything. Like much type of data is stored in like very, like it's all very complex data. So how do we sort that? Now the second topic comes is 5 V's of big data. As we discussed: volume, velocity, variety, value, and veracity. So these are like five basic V's of big data. Volume means how big is the data, how massive scale is the data. Basically from terabytes to exabytes of data generated continuously. Now, value. What is your valued data? Like extracting what is of our value, extracting the meaningful insight of, right, and business value from complex data patterns. Velocity, how fast data travels, like high speed data generation requiring real time and near real time processing, right? Like how fast we are generating the data and how fast we are fetching the data. Variety, the diverse type of data, like text, images, video, social media, like links, text formats, everything it has. So basically, veracity includes the quality and reliability of data, like what quality of data we are getting, and it can be uncertain, it can be incomplete, it can be like half of the data is coming and half not. So it depends, like what kind of veracity we have, like in data. Quality and reliability are main patterns. Now, big data and technologies. Basically, we use Hadoop system, Spark, and cloud platforms. Like Hadoop is basically what HD, like distributed data, which HDFS, like a Hadoop distributed file system. Okay, MapReduce for parallel processing across clusters, Yarn for resource management, and job scheduling. And for Spark, in memory computing for 100 times faster data processing. Real time streaming with Spark, machine learning with ML lab, and graph processing, right? So AWS cloud, Google Cloud, we have Azure Big Data Services. We have there are different cloud platforms which are provided. Scalable storage and compute resource on demand. Managed services reducing infrastructure and complexity. The basic agenda of of this services is to manage services to reduce the infrastructure complexity. To basic what we have to do from big data is reduce the complexity, extract the data which is of our use. Now, what is data processing pipeline? So, basically, ingestion, storage, processing, analysis, and visualization. This is the like how much time does it takes in this. So, basically, it's data ingestion, like collecting data from multiple sources like API database and all the streaming platforms. And data processing is the cleaning, transforming, and aggregation of raw data, like raw data that is in different formats or not usable formats for analysis. So we are going to talk about this. And real world applications, we have our data is big data. We have real world applications like nowadays big data is used in every other sector, like healthcare, we can say e-commerce, we can say industrial purposes and all. But yeah, so in healthcare, the predictive analytics for early disease detection it is used. Like a lot of data about a patient is stored, and from that we can predict early disease. Like it can help in early disease detection and patient monitoring to IoT devices and wearables. Yes, it happens. And drug discovery acceleration through genomic data analysis. Basically, drug detection can be done through this. And about healthcare, this is all. And e-commerce personalization, personalized product recommending increase sales by 30%. I mean, basically, big data is used like Amazon, Flipkart, everything. In this big data is used like you see the personal recommendations in every other app nowadays. Like you see a T-shirt on you see a T-shirt on some other app, and the next day you see the same, like almost the same product on other app. So it's basically work on how like your data is you are using the data. So it shows your personalized recommendations on every other app. Okay, and it's shared, yes. And customer behavior analysis for targeted marketing campaigns, and inventory optimization through demands and forecasting. Basic, this is the very basic like real world applications we have discussed here. Like it can be used in stock markets, like analyzing how the stocks will grow or when, you know so there are multiple applications of big data that can be used. It's used in educational sector as well, to analyze student growth and everything. uh, these are like some of the uses of big data. It's used in every other industry nowadays. So yeah, now big data impact statics, like uh, zettabytes by 2025, billions used USD markets 274, annual growth rate 40%, enterprise adopting it's 85%. Now every other enterprises is adopting big data. Now industry transformation, like big data is revolutionizing, okay, every sector from retail to healthcare, manufacturing to finance, 50% reducing in operation cost through predictive maintenance. Now 30% increase in customer retention via personalization. Like I just as I told that depends on your personalized recommendations. Like 30% increase in customer retention. Yeah, 25% improvement in supply chain efficiency. One of the major changes, enabling breakthrough innovations in AI, Internet of Things, and autonomous systems. Now, real-time fraud detection is one of the like life-saving thing. Yeah, one of the major saved thing, like real-time fraud detection saving billions annually, like billions. Smart city initiative optimizing urban living. Okay, and precision agriculture increasing crop yielding by 20%. Yes, big data in also helps in innovation drivers, like in crop detection, like uh, crop disease detection systems uh, is used, and how we can cure that thing. So basically, agriculture sector is also increasing by 20% in this. Risk management, proactive identification of mitigation of business risk. Yeah, cybersecurity threats like as I told, fraud detection, like same cybersecurity threats detection and prevention. It can be done by that. And financial market and risk assessment and modeling, compliance monitoring and regulatory reports and all are also one of the major risk management that they provided big data. These are the big data impact statistics, and like this are according to the main chart. So yeah, and for this, future trends in big data. This is basically real time application. Yeah. So AI and machine learning, edge computing revolution, and privacy preserve analytics. For AI, basically it's the artificial intelligence or the AI advanced algorithm which automatically discover patterns and insight without human intervention, making data analytics more accessible and powerful. So there is no human intervention. So basically it makes it more accessible and more powerful, more not degrading. Yeah. So edge computing revolution, processing data closer to its source will reduce latency and enable real-time decision making for internet of thing devices like IoT devices and autonomous systems. For the third one, it's privacy preserving analytics. Like new techniques like federal learning and different privacy will enable data analytics while protecting individual privacy and meeting regulatory requirements. Just like in the previous slide we said, like risk management and all. So yeah, it directly compensates the fact that privacy preserving analytics. Yeah, and for all, thank you for like for your attention, and if there is any question you can comment down. And yeah, question and discussion are welcome as we explore the transformation power of big data together. Thank you for your time, and this is my final assignment for big data, as my mentor uh, really helped me in this, Mr. Anurag Punde. So thank you all for your attention.